Hello and welcome to Kent Thinks Discovers. For our final episode, we'll be screening the science of making babies and finding out how a team from the University of Kent have helped to transform the lives of aspiring parents around the world through IVF. A little later on, we'll be talking to Professor Darren Griffin and Honorary Professors Alan Thornhill and David Brown from the School of Biosciences at the University of Kent. They'll be on hand to answer your questions, which you can send in on the live comments panel on YouTube and on Facebook. Now, as we're all obviously remoting in from our various homes, we may encounter some technical glitches, so do bear with us as we look to sort those out. That's all from me for the time being. I'll be back a little later on, but first, here's the science of making babies.
So that's the sac, pregnancy sac, and that's the yolk sac, what you see here. And so that's the fetal pole, and you can see the fetal heart pulsations there.
I feel like it's still your eggs, and all that is happening there is just that they're assisting the conception.
I was 26 when we started the process, my husband was 27, so everyone kept saying, you know, you're young, it'll happen.
Ours was unexplained, so they couldn't explain why, so biologically there seemed to be no real issue why you couldn't.
Which I think is very common as
well. And that is a very common, and that actually, from a point of view of selling the concept of IVF to people, if somebody said that there's nothing wrong with you, people may be more willing to take that first step.
In the UK, 1 in 50 births are now as a result of IVF treatment, and problems conceiving are very common, affecting an estimated 1 in 7 couples. In vitro fertilization is the process of taking either harvested or donated eggs and sperm and introducing them together in a lab environment to create a fertilized egg or embryo. The embryo is then transferred to the mother's uterus, where it implants and continues to grow as a naturally conceived baby would. IVF treatment is used for many reasons, most commonly in cases of a low sperm count or low sperm motility in the male partner, or blocked or damaged fallopian tubes in the female partner. It can also be used to create children in same-sex and single-parent families, where either donor or previously frozen eggs or sperm may be used instead. The process was first successful in 1978 with the birth of Louise Brown, the world's first IVF baby. Today, IVF is a well-established practice, and at the University of Kent, Professors Darren Griffin and Alan Thornhill are actively involved in the practice, regulation and future direction of IVF.
So this is my research lab at the University of Kent. We're very interested in the mechanisms of how IVF works, and to do that we look at pig and cattle embryos as model systems.
It's important to remember that this lab is a research lab. There's no clinical human IVF activity going on in there.
But much of the things that you'll see, the equipment, the procedures and so on, are pretty much as will go on in a regular IVF lab. There are reasons for doing cattle and pig IVF just on their own, and that's to do with food production. But as a model for human IVF, as large mammals, cattle particularly has an awful lot of similarities in terms of their embryos to humans. Having a working lab on a large mammal species really gives us an awful lot of advantages to understanding some basic questions about IVF.
For women, IVF treatment starts with medication. Regular injections over a 2-week period cause an increased production of eggs, allowing doctors to harvest many at once to improve the chances of fertilization in the lab. The sperm is either introduced to the egg, where the strongest sperm will penetrate the outer layer of the egg to fertilize it, or in cases of low sperm count or motility, a single sperm will be injected into the egg in a procedure known as ICSI, intracytoplasmic sperm injection. After 5 days, the embryos are assessed, and to avoid multiple births, usually 1 embryo is transferred at a time.
We've been trying for Joshua, for a baby, for about 4 years with no success. So we sort of arrived at the decision for IVF based on sort of doctor advice and referral, really. after lots of medical tests and things like that. So yeah, it wasn't something we necessarily chose, but it was a choice that we were given in order to try and conceive. Actually getting to the IVF process was a long road. We went obviously through the NHS, which involves lots of different tests. You have to qualify, so you have to be under a certain BMI, non-smoker. They're very thorough with their testing to make sure that you're good candidates and that there is nothing else that they can do naturally, because obviously it's an expense, a big expense on the NHS to put somebody through a round.
In the UK, the regulatory body NICE advised that women should receive 3 cycles of IVF on the NHS if they are under 40 years old, and 1 cycle between 40 and 42 years old. If NHS cycles are unsuccessful, no further treatment is offered, and women are left to pursue private treatment instead. In recent years, however, the NHS in certain areas of the country has cut access to IVF treatment.
Obviously, there is a health budget and it's got to go around a limited number of people, and all treatments in all areas of medicine are getting more and more expensive.
Our treatment was NHS funded. We were lucky enough in our sort of postcode lottery, they call it. Now we've had what they call a live birth, then we're no longer entitled to any more free NHS treatment.
Our first treatment was NHS anyway, so we were very lucky. For me, I always felt like he was more special than anybody else type of thing, because at that moment nobody else ever had to go through this, you know, this sort of situation, which of course they have. Certainly that first week of euphoria and being, you know, sort of 37, you know, you do think that potentially was something that was never going to happen. I would hate to think anybody that wanted to have a child that didn't have any children was denied it because they couldn't afford it.
One of the ultimate aims of IVF research generally is to make it better, to make it as successful as it can possibly be. So the ultimate aim, of course, is that a couple will come in and they will have one set of egg collections, inseminations and so on, and they will get pregnant from that.
I really don't think the reason it's not funded is because it's not 100% effective or 50% effective. I don't think there's a group of people sitting around saying, once you get to this percentage success rate, we'll fund it. I think it's just quite an easy thing to cut.
Although IVF is now commonplace, there is still much to improve, and Professors Griffin and Thornhill are at the forefront of continued research.
The thing that we've been interested in for a long time is the idea of chromosomal disorders. So this is gross genetic abnormalities and how they can affect fertility. Now we do that both in humans but also in model systems such as cattle and pigs as well. So what will happen here is we will receive ovaries and sperm samples. From the ovaries we'll get the eggs from them, get them into a sterile dish, and then ultimately we will move over to this cabinet here, from which we can then expose the sperm to the eggs, hopefully to achieve fertilization. The advantage of being able to look at pig and cattle embryos is we can look at large numbers without quite so many ethical constraints that are obviously you would need to have with human embryos. So in that sense, we can look at a very large number of embryos and look at differences, some of the factors that might affect the chromosome number, factors that might affect the development. We can do that in a test system, and then when we find that out and we narrow down some of the criteria, then we have the opportunity then to move into humans, but perhaps on a little bit much more smaller scale.
Parents who are at risk of having children with genetic disorders can be offered testing of their embryos, with only unaffected ones transferred, so-called pre-implantation genetic diagnosis, or PGD. The London Women's Clinic offers both regular IVF treatment and PGD. Patients are consulted and scanned at satellite clinics, such as the one here in Canterbury. Today, Sejula, who is at risk of transmitting sickle cell disease, is here for her second pregnancy scan.
We couldn't risk having natural conception because it means the offspring could be sickle cell. We wouldn't know, and if there's a chance of that, then we would either have to terminate before actually giving birth, or you end up with a baby that is a sickle cell carrier.
Sickle cell disease is a red blood cell disorder, which is potentially life-threatening. IVF treatment with PGD means that Sejula's embryos can be screened before implantation to allow an embryologist to select only healthy embryos for transfer. Critics argue that this is the scientific community interfering to create a so-called perfect or designer baby.
Designer babies are a little bit of a myth because in the human setting you only have a very small number of embryos, and from that a small number of things that you could potentially look at. It'd be completely impractical to try and screen the small number of embryos that you have for things like good looks or intelligence or so on. So even leaving aside the ethical aspects, the practical aspects of actually doing some of the things that are brought up in the headlines of certain tabloids, it's not really practical to do. If you had IVF that included screening for cystic fibrosis, then one argument might be then if you then have a child who doesn't have cystic fibrosis, the cost and the effort and the emotional aspects of bringing up a child with that disease are far minimized.
We didn't have any more testing as regards to Down syndrome and things like that as anybody else would. We still were tested at 12 weeks of pregnancy. But yeah, I think we probably would have taken the testing because, as I say, it's such a long, hard journey. When you get to the end of it, you just really, really want that healthy baby. It would be doubly hard if little one wasn't very healthy.
IVF in the future, there's a lot of interest now in, for instance, making the embryos, freezing them all, and then waiting until we think the couple, and particularly mum, are physiologically ready, and then implanting one at a time.
One of the biggest challenges is to ensure that we're using the best quality eggs and sperm for patients. And we all know that people are delaying having their children, so I think we need a lot more fertility education for women to understand that, for example, if you were going to freeze your eggs, do it early, don't do it late. With some of the genome editing, the stem cell work that's going on, maybe they're not so distant after all. And maybe that would really crack the barrier to get to this 100% success rate, this one egg, one embryo, one child. That's the kind of holy grail.
When we actually got to hold him, just disbelief. I think it took a long time to think actually he's ours, and now we still look at him and we look at each other and think he's actually, you know, our baby and half of you and half of me, and that's all we could have ever asked for.
And I'm happy to say that Darren, Alan and David all join me now on the line, and they're here to answer your questions, which you can send in on the YouTube and Facebook Live comment panels. Darren, let's come to you first. Let's go back to the beginning. How did this project begin?
Well, I've worked in the field of IVF since my PhD, which began in about 1988. Alan and I worked together even then. And through various projects over the years, I've always kept a hand in the world of human reproduction. And then more recently, when I was at the University of Kent, when I moved here in 2004, one of the things I was very keen to do was to make the links again with some of the IVF clinics, and particularly with the London Women's Clinic, which is just around the London Bridge area and also in Harley Street. We got together, and then one of the things we were very keen to do was to try and build up a program that not only had a human element, but also had a basic science element using model systems like cattle and pigs.
We'll come to Alan shortly to get a little bit more of a picture of what the landscape is like now in the field of IVF in the UK. But wanted to just ask you, Darren, you said 1988 when you started, only a few years after, obviously, the birth of Louise Brown, almost 42 years to the day that she was born, the first IVF baby. How has the field been finessed over that period? Obviously, that's something that you've been working very closely on making it more efficient.
Yes, so I think first thing you can look at is success rates, just how much they've improved. The area that many of us have been involved in, however, is the idea of genetic diagnosis in an IVF embryo. So that can be for a couple who are at risk of transmitting a single gene disorder like cystic fibrosis, or it can be for screening embryos for chromosome abnormalities to try and improve those success rates. So it's had many ups and downs, and I have to say both the science and the social science have gone together very well over the years, such that in many clinics success rates are over 50%, but also the relation and the acceptance in the world at large is much more prevalent now.
Absolutely. Alan, coming on to you now, we heard at the start of that film that about 1 in 50 births in the UK are now through IVF. Besides the sort of the statistics there, what's the landscape now for IVF in the UK and abroad in terms of IVF? We heard Darren there saying a little bit about how the social perceptions of it have changed. What about in terms of scientifically and the number of people using it?
Well, yeah, absolutely. I mean, we heard in the film that it's, I don't know if they use the word routine, but it's a somewhat routine treatment. It is safe and effective. There's millions of babies have been born using the technique, and they appear to be, you know, give or take as healthy as children born from natural conception. In the UK alone, about 70,000 cycles of IVF are done every year, and that's probably only limited by NHS funding. Most of those actually, or the majority, are privately funded, or out of somebody's pocket. But if there was more funding, I'm sure there would be more cycles, because there's definitely a need. So what we're talking about is an accepted technique, socially accepted now. It's decades ago when people were a bit ashamed to talk about it. Those days seem to have gone. It's much more open to different lifestyles. So same-sex couples can use IVF. It's much more accepted generally. So it's changed the way we look at families, and that's a really positive thing. In terms of the science and the improvements, Darren's absolutely right that the success rates today are way better than they were at the beginning. Although I would, say a note of caution. The reason we want to keep doing research in this area is because it is safe and it is effective, but it could be safer and it could be more effective.
And what's been needed over that period, or what's been helpful over that period of time to get IVF to the stage of acceptance that it is now? Obviously, Darren talking about how it's been finessed over that time and how it's, as you said, it's routine. What has helped to get it to that stage of being routine? I guess maybe tell us a little bit about your involvement in this project and how that has kind of helped get it to that stage.
Well, yes, as Darren said, we've been sort of academic colleagues for decades now, but my career has taken a slightly different path. I haven't stayed in academia. I worked as a clinical embryologist, so a scientist working in the IVF laboratory. So I've seen firsthand, not only working in the lab, running the lab, interfacing with patients, clinicians, other stakeholders. I've even worked for the UK's fertility regulator, the HFEA. So I've kind of seen the business and the discipline and the medicine from lots of different angles. And I think the acceptance has largely come because it's a very well-regulated branch of medicine, and I think that gives the public confidence. So, when we hear about things like designer babies and three-parent families and all these kind of headline-grabbing phrases, when we know that behind that there's actually scientists and doctors and healthcare practitioners, along with regulators, making sure that it's done in a safe and effective way, as far as they can, I think that gives the public confidence. Add to that the sort of public endorsement of funding, it could be better, and you heard that in the film. But the fact there's any funding at all, I mean, we should also say we're very lucky to live in this country where we have regulated IVF and funded to a degree. Many countries don't have that at all. It's out of the patient's pocket and it's not regulated. So it's not a particularly safe or happy place to be in other countries.
Well, one of those beneficiaries from IVF, as we saw in the film, is David and his partner. David, thanks for joining this evening. Tell us a little bit about your and your partner's journey with IVF and what that process was like.
Good evening. So, yeah, we're very fortunate to be beneficiaries of all the hard work that's gone into developing the technology and moving it forward. I guess we were, just to frame on a time frame, we embarked on this journey back in 1999, and we're very fortunate to have our first IVF child in 2000. The journey is very interesting from I'm a scientist, so it's quite stimulating from a scientific perspective to learn some of the details of the technologies that were placed. But I think But as some of the things that have been touched on both by both Darren and Alan, in terms of the potential stigma associated with IVF, you as a parent, you are sort of saying there's something wrong. We're not able to conceive naturally. In our case, it was an unexplained, which, as was said in the film, is extremely common. And I think the right terminology, the normalization of this process makes it much more socially acceptable now than it probably was, even 25 years ago or 25 years ago. When I told my son at the age of 7 or 8, he was a test tube baby, as it was called originally. He was like, wow, that's a bit weird, but now you actually say the terminology of IVF is commonly used, and they have no stigma attached with the fact that they were helped this world by the technology of IVF. So we were very fortunate. And again, coming back to the funding, we were actually approaching. We approached the local. We moved to Kent, and we approached the local authority for some help, just in terms of diagnosing if there was an issue. We were going to go privately, but we were very fortunate with the postcode lottery, as was referred to as well in the film, that we're enrolled in a Kent had joined up with a deal with Barts in London to undergo a number of free treatments. So we were very fortunate to benefit from that with our first child. And then, and as said in the second, and also in the movie, that our second child, we actually had to go privately for that. But that was spurred on by the knowledge of the success rates that you could.
And you talked about having to have that conversation with your children, obviously very different to the traditional birds and bees conversation, as it were. What is that like, trying to explain it, and how do you explain that to younger children?
As I say, the fun part is to call it a test tube, as the old terminology, which gets their ideas of mad scientists and coming together to create life, and then you tell them the real detail of how it's happening, and it's actually just giving nature a hand, and that actually they're born just as naturally as everybody else. So the process after the gestation and delivery is just like normal. It's just the inception part that you've got a helping hand with. So they accept it fairly readily. And they like the idea that maybe they're a little bit special. But as Alan has said, it's 1 in 50 now, so it's becoming the norm perhaps for older couples.
And on that kind of subject of education, Darren, I want to come to you because obviously, academia has been at the forefront of this, and the research community, which you and Alan and David are all a part of, have really helped to pave the way with this research. How important is it to have and for people to support universities and the research community for projects like this?
Well, at the moment, it couldn't be more important, and not only to look at some of the clinical results, but as I've mentioned before, some of the results that surround the non-human studies, because they are very good basic models. And at the moment, of course, universities, because of the COVID crisis, are very much in financial difficulties. So at the moment, it really tells us an awful lot about not only how to make IVF better, but how we all started. How every last one of us started with an embryo, a single cell embryo that began to divide and then differentiate. And all those genetic diseases that we see in normal conceptuses, just as much as we see in the world of IVF, these are all basic research that we really need to do. So there could not be a more important time to be supporting and funding research.
We've got a few questions coming in on Facebook and YouTube. Thanks to all of you at home for watching and sending in those. We're going to answer those in just a second. But first, we've been sent in a very short testimonial by Dr. Giuseppe Silvestri, who works in Darren's lab at the University of Kent. Here's what he had to say about the research.
This is Dr. Giuseppe Silvestri. I am originally from Italy, but have been living and working in the UK over the last 8 years. I am currently based at the University of Kent, where my work uses model organisms to study how to improve IVF, especially the way in which we handle oocytes. I'm also interested in the nature of and origin of chromosome abnormalities and how to use pre-implantation genetic testing to increase pregnancy and live births. Even though I work with model organisms such as cattle, I hope that my research will ultimately lead to the development of strategies that can be readily translated into real benefits for human IVF patients, thanks to the many similarities between us and them.
Thank you very much to Giuseppe for sending that in. As I said, we've had a few questions coming in on social media. Darren, we've had a question from Camilla. She's asked, what can increase the success rates for couples in their 30s who have had 4 failed IVF treatments? What could be the issue? She says it's supposedly more issues with sperm and not the egg itself. What kind of comment would you have for Camilla there?
It could be a range of things, and one of the things that our next place to go in terms of research is to look at sperm DNA damage, and we're going to look at that in a great amount of detail. Obviously, even with a success rate of 50%, which is going very well, some people just have bad luck. If they're in their 30s, then they might want to be considering pre-implantation genetic testing for these chromosome disorders. And I know the London Women's Clinic, for instance, one of the many clinics that do that. So it is worth returning to their clinic and look at the options of some of the other things that they might try in order to see if they can be lucky the next time around.
Absolutely,
well.
Camilla. Thank you very much for sending that. Oh, sorry, Alan. Just over to you then.
Yeah, sorry. So what Darren's focused on rightly is the sperm leading to the embryo. So my comment would be, obviously we don't have all of Camilla's details, but if she's got normal embryos and they look like good quality when they're transferred, the other area to ask about is her endometrium, the lining of the uterus, because we now have a lot of research and test results to say that if that lining is not ready to accept an embryo, imagine a wave. A surfer trying to catch a wave. That's what an embryo is trying to do when it implants. So if the wave crashes too early, the surfer falls in and it all goes badly. So the same analogy would work for an embryo trying to implant. So she should ask at her clinic, and London Women's Clinic is definitely interested in this area of implantation, whether, because she's young, people don't tend to think that young women have any issues at all. And generally they don't have issues with their eggs and embryos. That's a rule of thumb. But she may well have some timing problem with her endometrium.
Absolutely, and I think it's really important that you both a point that you both raised there, that there's loads of groups and individuals that prospective parents can go to for help, and that's obviously available online. Alan, Darren mentioning earlier on about how there's a real focus on the research community now more than ever, obviously with the ongoing coronavirus pandemic, and I think one of the earliest stories that came out of the pandemic was the halting of several sectors of healthcare provisions, IVF being one of them. What's been the impact on IVF treatment because of the pandemic?
It's been huge. I mean, obviously, as a community, the IVF community, and I'm running a diagnostic testing lab, helping IVF labs, so I'm sort of on the periphery. But my day-to-day life is based on the activity of an IVF lab, even though I don't work directly in one anymore. We've seen a dramatic decrease in the number of cycles. Obviously, during the start of the lockdown, the regulator actually said to UK clinics, you must stop doing treatments, most treatments, not every treatment, but most treatments by a certain date. Because, as we know, the lockdown has begun to be eased, they've actually sprung back very quickly. But it's had quite a big impact on people's opportunity to either freeze eggs, have embryo transfers. And there were two main reasons for that. One was because they didn't want to overburden, in this case, the NHS with doing treatments that weren't related to COVID, COVID disease and the secondary effects of COVID disease, like more doctors having to be redeployed to other areas. And the other one was specifically if people got pregnant, They were concerned about what might happen during pregnancy. Since the early days, we know more now, and we don't think it's quite as dangerous to be pregnant if there's a chance of catching COVID. But we don't know enough. It's a new virus, a new disease. We know that much. It's new, and we're learning all the time. But certainly, as the next step on from our IVF clinic, I've noticed a massive drop in workload from April, May, and June, and July. It's just starting to pick up again. So if we don't get a second wave, a significant second wave, I think we're back on track. But I think the NHS will probably struggle to get back to where it was for quite some time.
There's quite a lengthy part of the film where it's discussed about that relationship that the NHS has with IVF. Alan, why is it such a threatened part of healthcare? There's obviously a lot of aspiring parents out there. Many of them will want to conceive naturally, but obviously can't. And having that provision there is crucial for them. Why then is it that IVF is so under threat in the NHS? Is it, obviously as a case of finances, is it something that can be made more affordable?
I think it probably could be made more affordable, but as I say in the film, even if it's not a question of saying if it was a couple of percentage points more effective, then we'd fund it more. I think it's an easy thing to cut because it isn't seen as a serious disease. And it's not the same as cancer. Nobody's trying to say it is. But it's very easy when money is tight, and everybody knows that money's been tight in the NHS even pre-COVID. It's very easy to say, let's fund this and not fund this. And I think IVF is an easy thing to get rid of. Actually, politically, it's not easy to get rid of, and that's good, because I think the patient community has banded together and said we should be heard, we should be taken seriously. But I would use another argument, not just the health argument, not just saying that infertility is a disease and the effects of not having a child have their own mental health issues. I would say there's a good economic argument for having a child through IVF if you can't have one through natural means. And that's as follows. You probably saw the news items that have been going around the world in the last week, that all the projections of numbers of people in different countries, in fact, it's all around the world, not just European countries, the so-called replacement rate is too low, and it's predicted to be too low. There will be more old people than young people at some point in the future in most countries. And one of the ways to tackle that is through migration, and another way to tackle that is through things like IVF. So actually it would probably be cost effective to help people have children so there are more children and therefore taxpayers in the future. Simple health economic argument.
We've had a question from Adrian on YouTube. Darren, maybe you want to take this one. What is your intention in using research on cattle and pig embryos to inform IVF? Darren, I'll let you take that one.
Yeah, so I guess it's twofold. So the first thing is that cattle and pig embryos, there is a very good reason for doing it in and of itself, and that is that you can promote food production by getting some beneficial traits into the breeding herd. So these traits might be disease resistance, so you don't need to give them far more antibiotics than you would ordinarily. And these changes are sustainable and they're environmentally friendly. So that's the first reason. The second reason is that cattle embryos, being they will eventually, like ourselves, develop into large mammals, are very good models for human diseases. And there are certain things we can do in cattle embryos, and IVF in cattle is the second most practiced than any other species apart from human. So first of all, the animals are quite genetically homogeneous, so you can look at the same changes in a number of individuals, but you don't have the same ethical constraints that you quite understandably have with working with a human population, because you can transfer an awful lot of cattle embryos and see what happens, as long as you stay, again, within the legal framework. So we're very interested in cattle as a model for human diseases and for human IVF in a way that, for instance, mouse, which is a classical one, you just couldn't do.
Thank you, Darren, and obviously thank you to Adrian for sending that question in. David, you told us obviously about that journey and that you've been through, you and your partner have been through that journey through through the NHS and obviously through the private sector as well. What did you find was the support like along the way? Obviously, you've got that support at the start of the procedure, but was there support kind of along the way through the pregnancy and maybe in those early stages of after your children had been born for you and your partner?
Oh yeah, so certainly there was support throughout the process, both from both the NHS case and the private case. All the teams, I have to emphasise how professional all the teams are that perform these activities, and they are very interested. They're dealing with people and they're human beings. It's not a production line. There is as Darren put it crudely, there's an slight industrialization of the process sometimes, but it's it's very, very much done on a personal, and they have a fantastic insight into the feelings of the individuals, and they realize what a stressful time it is. So I won't hide the fact that it is quite stressful going through this procedure. But they are incredibly focused on the outcome and looking towards to a successful outcome for them and for you. And in both cases, when post birth, the clinics involved were very keen to have us come back and show the results of theirs and our labour, or my wife's labour, to show these kids. And certainly up to the age of 1 year old, they were followed very closely, and in terms of ensuring their normal development, because again, I think research is still being done in terms of the process to birth, but at that time, the successful outcome was also followed up to make sure that everything was progressing normally postnatal. So yes, I've nothing but admiration and thanks to them.
That's good to know that support framework was in place. And the reason I ask is obviously we hear in the film about PGD and about screening now that's in place for children with those chromosomal disorders. Was that something you and your partner had available to yourselves at the time for that screening? And was that something, if it wasn't available, was that something that you would have considered?
Certainly at the time it was not available. I think things have moved on quite a long way in terms of diagnostics and single cell diagnostics since then, as Darren's alluded to. I think certainly we would have considered it within our family, the wider family of nephews and nieces. The firstborn amongst all our family was actually Jack, who had Down syndrome, my nephew. So we were very aware of potential chromosome abnormalities and what the issues associated with following up on that were, and certainly we would have screening. And I think in the film you heard about, some diseases like cystic fibrosis and sickle cell, and if you can screen these out pre-implantation, I think that's something that makes some logical sense in terms of, or if the embryo is not likely to be viable to go to a full stage. Similarly, there's a huge amount of potential heartbreak to fail at a later stage. So I think, we would have definitely considered having that done if it had been available.
It's obviously, there's huge ethical ramifications around the so-called designer babies debate. Darren, it's something that you've been really outspoken on, and you mentioned in the film that really it's not, it's not as practical to think of it in the sense of good looks genes and etc. But again, it is something that comes up time and time again in the headlines, and that must be quite challenging to tackle. And how do you get that message across, I guess, to people who have those ethical concerns?
Yeah, well, I think it's important to make the point that the UK has not only led the way in the scientific aspects of IVF, but also in the social sciences. And you'll be aware that our law school and social policy school work very hard in this area. We have to remember that it's not done in a vacuum. it's under very, very strict regulation. Alan mentioned the Human Fertilization and Embryology Authority, which is the regulatory body for all of this. And obviously, regulator often complain about this, that, and the other, but by and large, it's a sensible body that does a very good job. Now, when it comes to the likes of designer babies, we do have the practical aspects to think about, in that, on average, a couple will produce about 7 embryos. Now, if we're screening for a disease caused by a single gene, like cystic fibrosis, some of those embryos will have that disease. Some of them will be chromosomally abnormal. Some of them, the embryos will look so poor that we don't really think that they will develop. So you're already narrowing it down to a small number of embryos. Now, the idea then that you're throwing in good looks and intelligence and so on, which are caused by many, many genes, and you can't necessarily predict just by looking at the genes of the embryo. You're talking a whole levels of complexity there that not only is it highly regulated against anyway, but it's also very impractical to do. So this is sometimes the very hard message to get across, that let's concentrate on the things that we know, like the diseases that are caused by the single genes, like making the IVF process better. And like Alan said in the film, the 1 egg, 1 embryo, 1 baby is the sort of thing that we're all looking forward to achieving.
There's obviously that that argument that it is the science community playing God, but you know, you've obviously made a compelling argument there that it is targeting those genes and like cystic fibrosis or sickle cell that David spoke about earlier on as well, and potentially solving a lot of heartache further down the line. But where's that kind of bar set, I guess, and who sets that bar for, you know, these are the genes that we can tinker with, this is, you know, we don't go this far? How is that bar set and who determines that bar?
So again, it's a regulatory authority in this country, and various other countries have their own regulatory bodies. So the Human Fertilization and Embryology Authority, or HFEA, is huge. It has many committees and several that will consider these very problems. So at the moment, we went from, in the first instance, pre-implantation genetic diagnosis was only for life-threatening diseases. When that got established, they changed it ever so slightly to serious diseases. And these things are constantly considered and reconsidered. So we have a very strong regulator, and you know, quite frankly, in every IVF lab, they constantly inspect. So I think one of the messages that we need to get across to the public is a feeling of reassurance that we're not, as I said, working in a vacuum here. Even the research is very highly regulated as well. It needs ethical approval. We need to justify why we're doing it at each stage. So both practice and research, I can't stress enough, have a regulatory body, and they're very active indeed.
We're slowly coming towards the end of the panel, so if any of you watching at home have any more questions on Facebook or YouTube that you want to get answered, do send them in. We've had one from Christian who's asked, where do we think that the next non-incremental advance in fertility treatment will come from? Alan, I'll hand it over to you for that one.
Well, I think if we can treat women or their eggs to reverse some of the effects of aging, that would be an advance. That would be a non-incremental increase, because the biggest reason for IVF failure is advanced maternal age because of the quality of the eggs. So that's one. The second one would be, and I'm not advocating it, I'm just saying where the advance might come from. Everything we've talked about so far is about selection when we've talked about PGD, testing embryos. So we say, this is what you've got. Have you got anything that meets the requirements that you have? And the numbers are small. But if we could either improve those numbers, or we could use some form of gene editing where you actually change what's there, not just accept what's there, that could also be a game changer. Again, not advocating it, and it's not permitted at the moment. You can't do IVF and use a genome edited embryo, but certainly the framework could be there to do some research to see whether it's feasible and safe and effective.
And how far off are we to getting to that stage, Alan?
Fortunately and unfortunately, we're not far off at all. So I don't know if you and the viewers caught the story, I think it was a couple of years ago now, of the Chinese doctor who had created 2 babies that were, let's say, immune to catching HIV. And this was done through genome editing. So he kind of proved in principle that this could be done. He was absolutely slated in pretty much every community, scientific, ethical, medical community, for doing something that wasn't really accepted in the wider community. But he kind of proved what everyone thought was very close to being able to be done. In this country, to be able to do it, you would have to do a huge amount of research, and that's what this film is really underpinning, the need for research. You'd have to do a huge amount of research and safety trials to show that not only was it effective, but it was very safe to do. Again, not advocating it, but it's a huge advance in all of science, not just IVF.
And David, for those parents in the future that might be considering IVF, what words of advice would you have for them?
The first word of advice is go and talk to your local doctor or practitioner if you're having trouble conceiving, because it's that first step that set us on the road. We as a couple were trying for, like, as similar to the other couples mentioned in the film, we were trying for 4 or 5 years and nothing was happening. And so at that point you wonder, if you really do want a child, you have to make that conscious decision that you are really trying for a child, and talk to somebody to get help to explain what could be either explainable or, in our case, unexplainable, and just nature needed a little helping hand, and just talk to people. And actually, probably within your social circle of friends, there's probably people now, it's so much more prevalent that have undergone IVF, and they can help talk you through the pros and cons of the system. And to be honest with you, the final outcome far outweighs any pain along the journey, I would say.
Darren, a final thought from you. We've had this series of films that have obviously communicated the amazing projects that are going on at the University of Kent across a wide spectrum of academic disciplines. For the science research projects that we've been showing off, this one included, why is it so important to communicate science to a mass audience, and how can it maybe be done more successfully?
I think you could sum that up in 2 words: designer babies. Because, as I've tried to get across and do many times, it is a myth, and unless we as scientists tackle some of these headline-grabbing slogans with facts, then we really are lost. And again, with so many forms of communication that have been around far more recently, I mean, communication has been revolutionized even in the last 5 years. We need to get our message out and clear, and just to tackle some of this sloganeering that happens sometimes. It really doesn't do patients any good just to go around calling names like designer babies and back from in the 1970s, test tube babies. We sort of adopted it, but we moved away from it. Just simple scientific facts, clearly put across, I think, is the absolute key. And Alan and Dave and I are all very keen on being able to do that.
Food for thought there to end on. Darren, Alan and David, all thank you very much for joining in this panel this evening. And thanks obviously to you at home for watching and sending in those questions on YouTube and Facebook. Any of you that might have missed the start of the film or joined us a little bit later on, we'll be replaying it for you shortly. But before we go, if you wanted to catch up on any of those other films that we've been playing as part of the Kent Thinks Discovers series, you can watch them on the University of Kent's Research Impact YouTube page and on the University of Kent's Facebook page. They're all up there for you to watch, and there's obviously plenty of fascinating documentaries there to catch up on, and hopefully we'll be bringing some more to you in the very near future. Thank you for joining us tonight and for all of those previous films. That's all from me. Thanks for watching, and goodbye.
that's the sac, pregnancy sac, and that's the yolk sac, what you see here. And so that's the fetal pole, and you can see the fetal heart pulsations there.
I feel like it's still your eggs, and all that is happening there is just that they're assisting the conception.
I was 26 when we started the process, my husband was 27, so everyone kept saying, you know, you're young, it'll happen.
Ours was unexplained, so they couldn't explain why, so biologically there seemed to be no real issue why
Which
you
I think
couldn't.
is very common as
and
well.
that is a very common, and that actually, from a point of view of selling the concept of IVF to people, if somebody said that there's nothing wrong with you, people maybe were more willing to take that first step.
In the UK, 1 in 50 births are now as a result of Ivf treatment, and problems conceiving are very common, affecting an estimated 1 in 7 couples. In vitro fertilization is the process of taking either harvested or donated eggs and sperm and introducing them together in a lab environment to create a fertilised egg or embryo. The embryo is then transferred to the mother's uterus, where it implants and continues to grow as a naturally conceived baby would. IVF treatment is used for many reasons, most commonly in cases of a low sperm count or low sperm motility in the male partner, or blocked or damaged fallopian tubes in the female partner. It can also be used to create children in same-sex and single-parent families, where either donor or previously frozen eggs or sperm may be used instead. The process was first successful in 1978 with the birth of Louise Brown, the world's first IVF baby. Today, IVF is a well-established practice, and at the University of Kent, Professors Darren Griffin and Thornhill are actively involved in the practice, regulation and future direction of IVF.
So this is my research lab at the University of Kent. We're very interested in the mechanisms of how IVF works, and to do that we look at pig and cattle embryos as model systems.
It's important to remember that this lab is a research lab. There's no clinical human IVF activity going on in there.
But much of the things that you'll see, the equipment, the procedures and so on, are pretty much as would go on in a regular IVF lab. There are reasons for doing cattle and pig IVF just on their own, and that's to do with food production. But as a model for human IVF, as large mammals, cattle particularly has an awful lot of similarities in terms of their embryos to humans. Having a working lab on a large mammal species really gives us an awful lot of advantages to understanding some basic questions about IVF.
For women, IVF treatment starts with medication. Regular injections over a 2-week period cause an increased production of eggs, allowing doctors to harvest many at once to improve the chances of fertilisation in the lab. The sperm is either introduced to the egg, where the strongest sperm will penetrate the outer layer of the egg to fertilise it, or in cases of low sperm count or motility, a single sperm will be injected into the egg in a procedure known as ICSI, intracytoplasmic sperm injection. After 5 days, the embryos are assessed, and to avoid multiple births, usually one embryo is transferred at a time.
We'd been trying for Joshua, for a baby, for about 4 years. With no success, so we sort of arrived at the decision for IVF based on sort of doctor advice and referral, really, after lots of medical tests and things like that. So yeah, it wasn't something we necessarily chose, but it was a choice that we were given in order to try and conceive. Actually getting to the IVF process was a long road. We went obviously through the NHS, which involves lots of different tests. You have to qualify, so you have to be under a certain BMI, non-smoker. They're very thorough with their testing to make sure that you're good candidates and that there is nothing else that they can do naturally, because obviously it's an expense, a big expense on the NHS to put somebody through a round.
In the UK, the regulatory body NICE advised that women should receive 3 cycles of IVF on the NHS if they are under 40 years old, and 1 cycle between 40 and 42 years old. If NHS cycles are unsuccessful, no further treatment is offered, and women are left to pursue private treatment instead. In recent years, however, the NHS in certain areas of the country has cut access to IVF treatment.
Obviously, there is a health budget and it's got to go around a limited number of people, and all treatments in all areas of medicine are getting more and more expensive.
Our treatment was NHS funded. We were lucky enough in our sort of postcode lottery, they call it, Now we've had what they call a live birth, then we're no longer entitled to any more free NHS treatment.
Our first treatment was NHS anyway, so we were very lucky. For me, I always felt like he was more special than anybody else type of thing, because at that moment nobody else had ever had to go through this, you know, this sort of situation, which of course they have. Certainly that first week of euphoria and being, you know, sort of 37, you know, you do think that potentially was something that was never going to happen. I would hate to think anybody that wanted to have a child that didn't have any children was denied it because they couldn't afford it.
One of the ultimate aims of IVF research generally is to make it better, to make it as successful as it can possibly be. So the ultimate aim, of course, is that a couple will come in and they will have one set of egg collections, inseminations and so on, and they will get pregnant from that.
I really don't think the reason it's not funded is because it's not 100% effective or 50% effective. I don't think there's a group of people sitting around saying, once you get to this percentage success rate, we'll fund it. I think it's just quite an easy thing to cut.
Although IVF is now commonplace, there is still much to improve, and Professors Griffin and Thornhill are at the forefront of continued research.
The thing that we've been interested in for a long time is the idea of chromosomal disorders. So this is gross genetic abnormalities and how they can affect fertility. Now we do that both in humans but also in model systems such as cattle and pigs as well. So what will happen here is we will receive ovaries and sperm samples. From the ovaries we'll get the eggs from them, get them into a sterile dish, and then ultimately we will move over to this cabinet here, from which we can then expose the sperm to the eggs, hopefully to achieve fertilization. The advantage of being able to look at pig and cattle embryos is we can look at large numbers without quite so many ethical constraints that are obviously you would need to have with human embryos. So in that sense, we can look at a very large number of embryos and look at differences, some of the factors that might affect the chromosome number, factors that might affect the development. We can do that in a test system, and then when we find that out and we narrow down some of the criteria, then we have the opportunity then to move into humans, but perhaps on a little bit much more smaller scale.
Parents who are at risk of having children with genetic disorders can be offered testing of their embryos, with only unaffected ones transferred, so-called pre-implantation genetic diagnosis, or PGD. The London Women's Clinic offers both regular IVF treatment and PGD. Patients are consulted and scanned at satellite clinics, such as the one here in Canterbury. Today, Sedula, who is at risk of transmitting sickle cell disease, is here for her second pregnancy scan.
We couldn't risk having natural conception because it means the offspring could be sickle cell. We wouldn't know, and if there's a chance of that, then we would either have to terminate before actually giving birth, or you end up with a baby that is a sickle cell carrier.
Sickle cell disease is a red blood cell disorder, which is potentially life-threatening. IVF treatment with PGD means that Sedula's embryos can be screened before implantation to allow an embryologist to select only healthy embryos for transfer. Critics argue that this is the scientific community interfering to create a so-called perfect or designer baby.
Designer babies are a little bit of a myth because in the human setting you only have a very small number of embryos, and from that a small number of things that you could potentially look at. It'd be completely impractical to try and screen the small number of embryos that you have for things like good looks or intelligence or so on. So even leaving aside the ethical aspects, the practical aspects of actually doing some of the things that are brought up in the headlines of certain tabloids, it's not really practical to do. If you had IVF that included screening for cystic fibrosis, then one argument might be then if you then have a child who doesn't have cystic fibrosis, the cost and the effort and the emotional aspects of bringing up a child with that disease are far minimized.
We didn't have any more testing as regards to Down syndrome and things like that as anybody else would. We still were tested at 12 weeks of pregnancy. But yeah, I think we probably would have taken the testing because, as I say, it's such a long, hard journey when you get to the end of it, you just really, really want that healthy baby. It would be doubly hard if little one wasn't very healthy.
IVF in the future, there's a lot of interest now in, for instance, making the embryos, freezing them all, and then waiting until we think the couple, and particularly mum, are physiologically ready, and then implanting one at a time.
One of the biggest challenges is to ensure that we're using the best quality eggs and sperm for patients. And we all know that people are delaying having their children, so I think we need a lot more fertility education for women to understand that, for example, if you're going to freeze your eggs, do it early, don't do it late. With some of the genome editing, the stem cell work that's going on, maybe they're not so distant after all. And maybe that would really crack the barrier to get to this 100% success rate, this one egg, one embryo, one child. That's the kind of holy grail.
When we actually got to hold him, just disbelief. I think it took a long time to think actually he's ours, and now we still look at him and we look at each other and think he's actually, you know, our baby, and half of you and half of me, and that's all we could have ever asked for.